All right, we're going to talk about factoring trinomials in the form x squared plus bx plus c. All right, these are not that difficult. One thing you do need to know how to do is you got to be able to determine what multiplies to a given number. So you have to know your multiplication tables pretty well because you're going to kind of have to use them. So here is an example of a quadratic trinomial in the form x squared plus bx plus c. Now, the b and the c are just numbers. So in this case, I have 7 in the b position and the 10 in the c position. What I'm going to try and do to factor this is going to factor into 2 binomials like this. All right? And I'm going to help you set these up. They're pretty fast to work. This is kind of the backwards of doing FOIL. And you remember FOIL? And I'm going to FOIL through this when we're done so you can see how it works. When I am FOILing, what's here and here, remember those are my firsts? So what's here and what's here need to multiply to be x squared. So they're always going to be x and x. Now, what goes here and here are my lasts, right?
5 and 2.
Exactly, the 5 and 2. We need those to multiply to 10.
Yeah,
So,
have to add the 7.
and they got to add the 7. So these must multiply to 10, add to 7, and the 10 and the 7 come from here, and that gives you 2 and 5. And in fact, it's positive 2 and positive 5. So we have plus 2 and plus 5. And just to show you that this does work, if you use FOIL on here, your first is x times x, which is x squared. Your outers is 5 times x, which is plus 5x. Your inners is 2 times x, which is plus 2x. And your last is 2 times 5, which gives you 10. Remember that you need to combine like terms, which we have 5x and 2x, give you 7x. So x squared plus 7x plus 10. Now, a lot of times what can make this a little bit more difficult is when you have some negatives involved in the situation. So here is an example. So I have r squared minus r minus 42. And again, it's going to look like this. And same as before, r and r go here. Whoops, I put 44r instead of 42. All right, so since I have a negative 42 right here, it has to multiply to negative 42, right? So multiply to negative 42, and what does it have to add to?
Negative 1.
Add to whatever b is, which is negative 1. So up here, it had to multiply to 10, which is what c was, and add to 7, which is what b was. So this is your c, this is your b. Now, we have to figure out what that could be. So, for me, because I know my multiplication tables inside now, I can tell you what it is right away. This may be a little bit more difficult for you. So let me go over what a good strategy is to figure this out. We're going to start with this negative 42 right here. And we're just going to start thinking of things that multiply to negative 42.
6 times 6 is 36 plus 6.
So negative 42. What do we have that could multiply to negative 42? Now, don't forget, we could have negative 1 and positive 42, or positive 1 and negative 42, but those add to 41 and negative 41, right? So that's not going to work.
What about positive 6 and negative 7?
All right, let's try. Positive 6, negative 7. Yes, multiplies to negative 42, adds to negative 1, positive 6 and negative 7. So plus 6 minus 7. Now, if I put this guy here and this guy here, it's the same thing. The order of those two does not matter. You can switch them around however you like. So let's go over, let's see if we can find one more to go over. Okay. So what does it need to multiply to? 35. So we need it to multiply to 35, which we got from right here. And what does it need to add to?
Negative 12.
Add to negative 12, which we got from right here. So let's think about what multiplies to 35. 7 and 5? Well, 7 and 5 multiply to 35, that adds to positive 12.
Negative 5 and negative 7.
Negative 5 and negative 7. So negative 5 and negative 7 multiplies to positive 35, adds to negative 12. So x and x go here, minus 5, minus 7. Okay, I'm going to show you two different examples that are just an extension of what you've learned. And if you look at our first example here, what's different than what we had before is the fact that you also have a y squared here and a y here. And that just means you have one extra step, but it is an easy step. So again, since we started with x squared, as I've told you, you're going to put x and x in here. And you need to find out what multiplies to 6 and adds to 7. All right, so what multiplies to 6 and adds to 7?
6 and 1.
6 and 1. So we've got 6 and 1. So I'm going to put plus 6 and plus 1. Here's the extra step. Since you have a y squared with your lasts, you're going to put a y right here with your 6 and a y right here with your 1. Now, as you can see, we have one y written here. And you know that one y is really just y. So you don't need to have the 1 written there. You can just have x plus 6y, x plus y, and that's it. All right, so that's if you have an extra y squared at the end with a single y in the middle. The other one we're going to do is where we have x to the 4th and x squared instead of x squared and x, okay? And the only difference here is that when we start our two binomials, since we have x to the 4th here, this is going to be x squared and x squared, because x squared times x squared gives us x to the 4th. We still need what multiplies to 6 and adds to 5. So what would multiply to 6 and add to 5?
3 and 2.
3 and 2. So plus 3 plus 2. And you are done.